guys, welcome to Newast Science Practicals. I'm Mr Beardsall and today we're going to be investigating potential difference. To do so, you require a very important piece of apparatus known as a voltmeter. You can see the capital V on the front of the voltmeter. That's because we measure voltage in volts. Now, the term potential difference and voltage are used interchangeably at this stage. So when I use the term potential difference, please remember that we do measure that in volts. The first thing I'm going to do is I'm going to introduce the circuit to you. So as you can see, we have our circuit symbol for a cell, in fact multiple cells, so that's going to be a battery, and we have it in a continuous circuit as presented here. There's a part of this circuit you probably don't recognise, which is the fact that it's plugged into the mains via this cable, but it still behaves exactly like your cells would if you were to plug it in, direct current. For that reason, I'm able to change the potential difference going into the system, and I do that by flicking this switch. So the moment I have it set to a particular voltage. Let's see if the circuit works for once. Fantastic. So you can see I have two lamps lit up in series in this circuit. So if I let go of the switch, they turn off. I connect the switch, complete the switch, they turn on. So we want to know, in our investigation, what the potential difference is across the power supply. And we want to know what the potential difference is across the first bulb and then the second bulb. So we'll start by taking the potential difference across the power supply. So again, I'm using my voltmeter. Now the terminology is really, really important here. We're going to connect it across, which means in parallel with the components. So you'll notice that I've put not inside the circuit. It effectively, if you were to draw this, it would look outside the circuit. So it's in parallel, it's across the component. And if we have a little look at the number that we've got recorded here, we have 6.18. So I'm going to write that down. Now the second part we need to look at here is the voltage or potential difference of bulb 1 and bulb 2. So we're just going to move the voltmeter that we had our reading of 6.18 before. We're just going to move it to go across those other components. So back to 0, or nearly. And we're going to go and put it across the first lamp. So notice how it will read 0 until I complete the circuit. And we read it as 3.08. Just as we did this time, we're going to move the voltmeter to measure the potential difference across the second lamp. Complete the circuit, 2.92, 2.93. Now, I told you before that I can change the potential difference of the power supply here, so I'm going to change it. I'm not going to tell you what we're going to change it to, but we're going to change it. And we're going to do the whole experiment again. So once again, back to 0. And we have a new reading. This time we have it as 9.31. Cool. Let's do that around. So, back to measuring the potential difference of our first lamp. Complete the circuit. 4.68. And for the second lamp, complete the circuit, 4.39. Some of you at home are probably starting to see a pattern between these numbers. If so, well done. But we'll do our third and final potential difference. Let's see what we've got. And you'll see this one's reading 12.42. Same as before, we're going to connect it across our components. Complete the circuit. 6.27. And the last component, the second lamp, our last reading. Complete the circuit. 5.86. So, that completes our practical, and I think we can make a pretty confident conclusion here that, generally speaking, I was aiming for the power supply to supply 6 volts, 9 volts and 12 volts here. And if we compare the numbers we got for each component, you'll see that they are divided between the total supplied. Because this is a series circuit, the total potential difference or voltage supplied will be split between the two components based on their resistance. These lamps are very similar, so those numbers will be very similar. 3-ish and nearly 3. 4.6, 4.39, pretty close. This one's a little bit off, but 6.27, 5.86. We're looking for these to total our inputs from our power supply. And I think our results demonstrate that pretty well. Thank you very much, guys. I hope you've enjoyed the practical. See you in the next one.